My name is Joe Kizis, and I'm an exploration geologist. I'm also president of BravadaGold Corporation, which is an exploration company. We focus on exploring for major gold, silver deposits in the state of Nevada, one of the best jurisdictions in the world. So we've invited questions from shareholders and interested parties regarding the company, and one of the questions I get is, what about our Highland project? So that's a project that has been fairly dormant for us for a number of years, and we recently, in December of 2018, signed a deal with Oceana Gold Corporation, which is a major intermediate-sized mining company and exploration company with operations in New Zealand, United States, various other parts of the world. So, why did they suddenly take an interest in our Highland project? And our goal right now is to answer that question. Highland is a low sulfidation system. These systems produce some of the best gold deposits in the world. Very high grade, often over an ounce per ton, and they can be in districts that have tens of millions of ounces. So very attractive targets. They've been studied extensively. There's some new information that has been identified, in particular relating the modern hot spring systems that you see in geothermal fields with historic, basically paleo geothermal systems, which are now been eroded down to the level of showing their high-grade gold deposits. And we're seeing that, in particular, some recent information coming out of the University of New Zealand. Centers are fascinating geologic features because they are the top of where gold deposits are forming today at some depth beneath them. So this photograph here from Yellowstone shows a geyser, and the hot, boiling, steamy water that's coming out then condenses and forms these pools around the edges. They're high in silica, and they form a rock that we call sinter. So by the time the fluids get to this point at the surface, the paleo surface, they are devoid of gold. Most of the gold is dropped off at some depth beneath them, maybe 100 meters, maybe 300 meters. And at that depth where the boiling begins, gold precipitates out in these beautiful banded veins with high-grade gold and silver. These sinter pools can be quite large scale. They can cover aerial extents, usually several pools, can be on the order of square miles. So what can we use to vector us into the hottest part of the system, the part where the vent originally was? That's probably where the fluids originally came to the surface that are related to the veins at depth. So we have a number of features that we can see, and we have on several of our projects. One thing we see here, these are fossil reeds. This is typically what you see in sinters, most common as evidence of this particular rock being a sinter. Now, these fossils typically form on the margins of the deposit. If you get a little bit farther away from the conduits, you can see bits and pieces of things like this. Now, there's a piece of a twig. You can see the size of the twig here. There's how wide it is. This basically was a tree that fell into the pond. You really need to find out where the system is even hotter. So one of the features that we can do to see that is this is called bubble mat. Bubble mat happens when the sinter is boiling and you're preserving the fossil bubbles that are forming as a result of that boiling. So these are the tools that are kind of recognized now as being common in modern systems, like you see in New Zealand, like you see in Yellowstone, many places around the world, and they're preserved in these fossil systems that are related to gold deposits. Researchers in New Zealand have compared the modern hot spring systems that are associated with geothermal fields with the ancient deposits that are 5 to 16 million years older, and they found that a lot of the features are exactly the same. And so as they go from the conduit, which is basically where the spent ore fluids originally came to the surface, they can see that there are specific features that are preserved as fossils or as are forming today in modern systems that give you an indication of where you are in the system. So what I'm showing here are some photographs from two of our projects where we have extensive center at our Highland project and Wind Mountain. The conduit, which is where the fluids originally came to the surface and spread out over quite large areas, is often highly brecciated, as you can see from this photograph from Highland, which is an unusually rare condition where the conduit is preserved. So these other features, even though they're farther from the vent, they can be used to vector your way into the hottest part of the system, or at least narrow it down so the geophysics can be a lot more concentrated. What I'm showing here is a very simplified version of what we think happens with depth. So at the surface, if the fluids do come to the surface, we can see sinter forming, and because most of the gold's already dropped out at some depth below, it's pretty tough to see through this and determine where the high-grade mineralization may be. So at Highland, just like many projects in Nevada, which are variably weathered to different levels, on the western side of the property we have erosion that have eliminated all the sinter and well into the vein system, and our drilling has produced some pretty impressive grades, as you can see there, 12 meters of 7 grams, with some high-grade zones within that. So that tells me that this system is worth pursuing, even though the ore zones are going to be much more limited than the widespread sinter or the widespread veining that we see. So in part, the excitement at Highland is not just the existing veins that we've seen. Those may not be the strongest part of the system, but now we have a method of kind of focusing our exploration in areas of sinter where we know we're much higher in the system, and being able to focus a lot more detailed geophysics into targeting those areas for future drilling. So Highland's a good example of the type of projects that we like to acquire, things that we think have high potential for high-grade, large deposits. We'd like to bring in partners at a stage where they can bring in not only funding to advance the projects, but also ideally bring in some expertise that can be added to ours and for the benefit of our company. If you have additional questions about Highland or other projects that we have, periodically we'll put together these low-cost, simple explanation videos. You can post your questions on our website. Just go to the website, BravadaGold Corporation, and leave a message for our IR people. Thank you.